I get to weigh in on the designs for geology tools that will get to be used on the surface of the moon. And being able to help those engineers design those tools is really a beautiful thing. As a geologist, there's a lot of different ways I help support Artemis. One of those ways is to help with geology training. So helping to train engineers, managers, astronauts that are going to be the ones who will be walking on the surface of the moon. I'm Angela Garcia, and I'm an exploration geologist here at NASA Johnson Space Center. These NASA tests that we do are like dress rehearsals for when we send humans back to the moon with Artemis. Gray float in bag number 3574. And so it's really about empowering them and teaching them everything that they need to know to really be field geologists on the moon. It's sending astronauts that are well-trained and able to pick up the best samples that then can be brought back to Earth. So we train in a lot of remote locations because we want to be as lunar-like as possible. Every location that we choose to test in is for a different reason. So the desert, because it doesn't have a lot of vegetation, and there's no vegetation on the moon, and so we want to have bare rocks and large geologic formations that we can test in. And so we want to remove some of the sense of scale that people feel. You really have to rely on more fundamental kind of navigational skills. Iceland is great because they have a lot of frozen, icy soils, and so that's a pretty analogous thing to what we would expect to see on the South Pole of the moon. When you do the end-to-end mission sim, there's a lot of lessons that are learned because you're forcing everyone to integrate together. For the astronauts, they're responsible for navigating to all of your stations. They're trying to describe the landscape and describe the hand samples and collect the right samples that meet your science objectives, all while being able to navigate to where they are and how they can safely go back to the lander. And so we're really all trying to learn together how we can communicate with each other and what's the best ways to enable our science objectives. When we went to the moon in Apollo, we went to equatorial regions on the moon. And so for Artemis, we'll be going to the South Pole. And so all of those samples are new and diverse to us. It's really important to get physical samples back from the moon because scientists here on Earth can study them and learn more about the history of our solar system. A lot of the rocks that were formed on the moon were formed from its initial formation. So the rocks that astronauts would pick up on the moon are really, really old. It can help us learn about Earth's history. So the Earth is a really dynamic planet in that it has plate tectonics and things subduct and things uplift. You are eroded and subducted and recycled. But on the surface of the moon, the rocks that initially formed there are pretty much the ones that are still there. So I grew up on Hawaii. Hawaii is amazing because it's really remote. And so when it gets dark, if you know how to get out of the light pollution of the city, you can look up at the stars and just be really inspired about the world around us. I think I've always been pretty interested in the natural world around me. Like going to swim in the deep ocean or going to hike in the mountains and going to volcanoes on Big Island was always just a part of my life growing up. And I knew I wanted to learn more about why those are there and Earth processes. And so when I first took a geology course, Geo 101 Day 1, like mind blown. It was all fascinating to me. And then I think every course that I took that was related to geology was like mineralogy is a thing. Like you can, like crystals, what? Like all of it started to get really, really exciting. And so I knew I was on the right track. So like most students in college, I didn't have a lot of money and I didn't have a car. So I started really working in a lab at my university, washing labware for the graduate students in that lab. But that ended up being a really awesome opportunity because I was able to be immersed in the science that they were doing with passionate people. Really a cool thing to be a part of. I actually found out about internship opportunities at NASA through the undergraduate research I was doing. I think advice I'd give myself would be to have more confidence. It's really just, if you have hard work and initiative and good vibes, you can really get pretty far. And so to really keep that at the forefront and to just keep pushing, because I think I was really hard on myself when I was younger. And it's okay to not know exactly what you want to do, but to keep following things that make you happy.